Hi everyone, my name is Sophie Goodwin. I'm a second year master's student in sociology at UNH, and this summer I've had the privilege of working at the New Hampshire Department of Environmental Services. I've been working with the Technical Services Bureau of the Air Resources Division to complete and compile the State of New Hampshire's 2022 greenhouse gas emissions inventory, as well as data visualizations for use in the New Hampshire Comprehensive Climate Action Plan. My team, including my mentors Jen and Kurt, has been working diligently to complete this plan prior to the EPA deadline later this year, as the effort was made possible by the EPA's Climate Pollution Reduction Grants Program. My work builds on the 2021 greenhouse gas inventory, which was completed in 2024 for the more introductory Priority Climate Action Plan last year. And before I start the presentation, I also do want to thank the Responsible Governance and Sustainable Citizenship Project for supporting my fellowship and making this project possible. So creating a greenhouse gas inventory for an entire state is obviously a massive undertaking that has been made more approachable by EPA-sponsored software programs such as the State Inventory Tool or the SIT tool, which provides a useful framework for state agencies to calculate their inventories dating back to 1990. So on the left here, you can see the 12 modules I did use this summer. I spent much of my time this summer getting even friendlier with Excel. But the SIT tool provides sector-based modules such as mobile combustion, stationary combustion, agriculture, etc., which I was able to populate with a mix of default data, which is provided by the EPA, and other federal jurisdictions such as the Energy Information Association, as well as data I researched on my own using state-level, private, or disaggregated federal sources for some modules. For much of my fellowship, I was able to use work that was completed last year for the 2021 inventory as a guide, but I did improve upon these previous methods to provide a more comprehensive inventory, such as using natural gas and oil data from the EIA in order to populate that one, which does not have default data. So I completed all 12 modules, checking the validity and comparing to the previous inventory along the way. And once I finished them all, I compiled their outputs and plugged them into the SIT synthesis tool. And then I was able to use this summary to translate the categorized data into DES's preferred sector sources, which I will get into on the next slide. Lastly, I checked the data for accuracy and both internal and external validity before jumping into data visualizations and projections. And all of this will be used for the Comprehensive Climate Action Plan, specifically its own chapter for the greenhouse gas inventory. So, as I mentioned, NHDES, like other states, uses different sectors in the SIT tool, providing a methodology based on the emission sources. So, for example, the SIT module, carbon dioxide from fossil fuel combustion, quantifies emissions from combustion within transportation, residential, commercial, industrial, and electric power. So, for that module and other similar ones, such as stationary combustion, I extracted the emissions from each source sector to quantify the new categories DES prefers. So you can see them all here: transportation, residential, electricity, etc. One of my main deliverables for this project was to create pie charts of the data similar to that of the PCAP, and you can see my completed pie chart using updated data here. I also came up with other ways to communicate data, which, as you can see here, is a bar graph in millions of metric tons of carbon dioxide equivalents, including sequestration, where New Hampshire's land use sector contributes to sequestering over 8 million metric tons of carbon dioxide equivalents. So each of these charts is using the same data, but with the addition of the huge carbon sink that is New Hampshire's natural lands and forests, they will tell very different stories. So lastly, I wanted to discuss the impacts of this comprehensive greenhouse gas inventory and the projections both to NHDES and other stakeholders, and for me personally. This inventory establishes and progresses a historic record of emissions and provides an updated baseline for future modeling to situate progress now and later. It also provides great data for use by policymakers who may want to promote electric vehicles because of transportation being a large emitter, for example. It allows for stakeholder engagement using quantifiable metrics, tracks progress over time, and quantifies emissions by sector and their relative impacts. Also, in general, once this starts, then it's able to establish a sort of responsibility to continue making greenhouse gas inventories in the future. And as for impacts on me, it means a lot that I've been trusted with such a large task that will hopefully drive change and increase climate action and capacity in my state. I've been able to work independently, multitask, build confidence in extremely large scale accounting, and manage lots of data. I also had an awesome experience working as a state employee and being introduced to an office environment, which really motivated me to stay focused on my project. Next slide is just saying thank you before I sign off to my mentor, Jen Galbraith, for her constant support, sense of humor, trust, and understanding. My other mentor, Kurt, for his empathy and great ideas. Some team members such as Brendan Wyman and Michael Rieger, and other DES employees who supported me and allowed me to be their coworker. Chris Skoglund for his assistance with the nitty-gritty numbers. And my advisors, Kiera, Kat, and Cassidy for constant ideas, support, patience, and brainstorming. Thank you, and thank you for listening.